This morning we will speak about something that you have already partially seen in one of the lessons before, because it is related to the lab that you have to work on. Specifically, we will speak about high-resolution global land cover, which is a fundamental layer for many GIS and in general the study of the Earth. And we will see specifically the tools that are available for intercomparison and validation. And we will concentrate at the end on a tool that was developed by a student here using QGIS. It was developed by a student during her thesis, and then she refined the software. You will see that there are scripts for, or better plugins for QGIS. Now she's refining this software during her PhD. Okay, let us start with the general context of the reason why we are interested in that. First of all, land cover is really a key class of global geospatial datasets. We can apply land cover in many different fields like planning, studying nature and biodiversity, natural resources management, and generally the land cover is considered as a key input to monitor the indicator of the Sustainable Development Goal of United Nations. Specifically, one of the main usage of land cover is to study the problem of soil consumption, so urbanization and deforestation. If we look at the products that are available, we can start with the products of the European Commission. And the main product of European Commission is this CCI land cover that is available at 300 meters resolution. You can see here the website where you have all the pieces of information about this product, and specifically you see the it is provided through this WebGIS. I have to add nothing about WebGIS because you know now what the technologies of WebGIS are. So you can understand also what is behind this WebGIS. And as you see here, there is the map of all the world. And we can zoom in and zoom out, so we can move in the map. And we can read what is the land cover considering the available legend. From the technological point of view, I have to add nothing because you know how it is possible to create a WebGIS like this one. Okay, what is interesting is that in this case, the WebGIS allows us also to download the data. You see here there is a button, download the data, and you can download the data related to all the world. We have many different data sets corresponding to different years, and specifically if we concentrate on some years, we can see the change in the territory. For appreciating the change in the territory, we have before to give a look to the legend. And this is the legend as you saw before in the WebGIS. I want just to highlight for you that this legend is based on what is called LCCS, which is the Land Cover Classification System that was developed by FAO. So related mainly to the problem of food, agriculture, and so on. And this system is a system allowing us to match the different categories of the land cover. You have to consider that there are many national land cover maps exactly as we saw with respect to many other kind of topographic maps or database maps. And generally, those land cover maps are not using a unique way for classifying data. Therefore, we need to have something allowing us to create the match between the different land cover maps of the different countries. Okay, so let us concentrate on this legend, and specifically, I want to you to give a look at the color corresponding to the urban areas, because what I want to underline now is the phenomenon of urbanizations in the last years. So the urban area is the red one. Okay, let us consider the situation around Milan. This is Milan. You can see here it's written Milan. And this is the land cover map in 1992, so 20 years ago. Let us see what is the map of land cover today, or not today, in 2015, as a matter of fact. So you can see that now on the map of 2015, we see much more red. It is much more reddish, this map. So it means that the urbanized area has increased in time, starting from 92 to 2015. And you have to consider that the problem of urbanization, together with the problem of deforestation, is one of the main reasons for the climate change. So we have to be very carefully in studying this kind of phenomena. So this is the situation here in Milan. Let us consider another situation. Let us consider, for instance, the situation around Hong Kong, in the Bay of Hong Kong and Macau. Just two examples. This is the situation in 1992, and this is the situation in 2015. So you see immediately how much more red you can see in this map. So how the urbanization has increased in these 20 years. If you want to play with the WebGIS that is available, you can do the same also for your city or cities around, and you will discover that in many parts of the world the phenomenon of urbanization was really impressive. Also in some part of the world, like for instance Africa, where the cities have been becoming mega cities in the time. Okay, I was mentioning the question Africa, and what is interesting is that now the European Commission decided to go toward a better resolution land cover map. It was seen that a global map at 300-meter resolution is not enough. We have to decrease the resolution, or better, to decrease the size of the pixel if we want to use it in the models for studying the climate change. And therefore, now we have to reduce this pixel size. Is it possible now to do that? The answer is yes. You have to consider that those maps are maps derived mainly from satellite imagery. And in the last years, we saw that the European Space Agency launched some new satellites. Specifically, they are called the Sentinels, providing data at definitely higher resolution than before. Now we have multispectral data at 10 meters of resolution, and therefore definitely we can compute land cover maps with a better resolution than the 300 meters. Okay, let us have a look at this map. This is a prototype land cover map for Africa with a resolution of 20 meters. There is the website where you can read everything about the map, and if you are interested, you can also download the map, keeping in mind that this is a prototype. So if you want to use it, you need to validate before the product. If we look at this map, you see there is a WebGIS showing the map. It is not how to say, you have less functionalities than the WebGIS before, but the logic is the same, so you can zoom in the map and so on and so on. We have to add nothing because you know how to build a WebGIS. You see that the main difference is that in this case we are considering less classes. Specifically, we are considering only 10 classes for this product at 20-meter resolution. So less detail, but with respect to the categories, but a better detail with respect to the spatial resolution. This map is only available at the moment for 2016. Okay, the question is, do we have also other global high-resolution maps? And the answer is yes. We have two global high-resolution land cover maps with many categories, and both of them are produced in China. The first one, which is from GLC, is a product of the Tsinghua University, and we have the map corresponding to 2010 and 2015. The second one, on the opposite, is not produced by a university, but is produced by the National Geometric Center of China, which is the cartographic agency of China. So this is the authoritative map, can be considered as an authoritative map, and it is available, it is produced at 30-meter resolution. It is available for 2000, 2010, 2015 only partially. 2015 by now is available just for one part of Africa. It will be available for all Africa by the end of this year, and it will be available for all the world next year, the 2015 map. Then we have other global map, high resolution map, but they are more specific on one specific category. Like, for instance, this global water surface of 30-meter resolution, and it is available for many years in such a way that you can see the evolution in time of the water on the planet. Then we have some maps related to trees, forest, and so on. Specifically, this map produced by the Japan Space Exploration Agency. You see 25-meter resolution, and you have these two maps, one corresponding to the period 2007-2010, the other one 2015-2016. But then, with respect to trees, we have also these maps produced by the University of Maryland. And you see that the resolution is more or less the same. And the period is 2000-2012, 2000-2015, or 2000 for the tree cover. Then we have maps that are specific for urbanization, so the urban footprint or urbanization. And you see that we have a map produced by the German Aerospace Center, and the resolution is very good. This is only related to the cities, the main cities. And then we have this other product that is produced by the Joint Research Center at 38-meter resolution. Okay, with respect to this one, the Global Human Settlement Layer, we will have probably a seminar next year during the course, but also you are invited, obviously, for better explaining how it was produced and so on, because it is produced also in ISPRA, so in the same place of the people that gave you the seminar this year. Okay, let us consider, because we see that we have many maps, but we have only two maps that are complete in terms of categories, and therefore, as the first one is produced by the university, the second one is the authoritative one, we prefer to concentrate on the authoritative one. There is a website where you can obtain many pieces of information about this global map that I repeat, is a map of 30 meters of resolution for all the world, and those are the 10 categories that are considered for this map. And if you want to have more pieces of information about how the map was produced, starting from satellite imagery mainly, you can download this paper and read everything about the production of the map. Or if you want simply to play and to verify what is available about the map, you can go to this website and verify what is available. One of the possibilities is also to download the data, because the data can be downloaded for research purposes. And therefore, you can download the data, and for instance, if you are interested, you can compare the map of Africa that was produced as prototype by Europe with the map that is produced by the Chinese government, to see if they are comparable, where there are differences, and so on. Okay, let us consider the classes. Luckily, in this case, we have that the classes are more or less the same. So you can see that in case of Globe Land 30, we have these 10 land cover types, and they are more or less the same land cover types that we have for the prototype for Africa. So with respect to that, we are enough lucky, because the matching is easy. In some other cases, it could be that the categories are much more interleft, and therefore there are difficulties in finding the optimal matching between all the classes. Okay, with respect to Globe Land 30, you can see those are slides that were provided me directly by the people of the National Geomatic Center. You can see that the usage of the map in time has increased a lot in the year. You see that at the beginning, only 39 countries were using this map. On the opposite, now the countries using for different reasons this map has increased to 131. So it means that it is really a product that is used by many, not only researchers, but also agencies at worldwide level. And they wanted also to better understand which are the main usage of the map. So for verifying that, we can check this table, which is summarizing the usage, the reasons or the field in which Globe Land 30 was used. And if we consider an average value with respect to the usage of university, research center, governments, NGOs, and United Nations, others, and so on, we see that the main reason of usage of this map is for studying biodiversity and, in general, the ecosystem. But we have also other usages, like studying the sustainable urban development, water resources management, disaster resilience, and also some cases that seems to be enough far from this kind of map, that is, are problems related to infrastructure and transportation management. So it is very wide, the usage of this kind of map. Okay. At this point, we have the complete overview about the maps, the global maps that are available. The point is that generally in the developed countries, we have also higher resolution land cover maps. Like, for instance, if I consider the situation in Italy, we have higher resolution land cover maps for the different regions in Italy. Like for Lombardy, we have the land cover map for Lombardy, that in case of Lombardy is a map at scale 1/10,000. So with an accuracy of more or less 2 meters, that is definitely better than the 30 meter provided by the global land cover 30. But the situation is not homogeneous also in Italy. So the different regions in Italy have different land cover maps. And some of them are updated, some of them are not updated. And it happens the same in many other countries. There is not an homogeneous situation, unfortunately. And in some cases, the classes, so the categories that are used, are different each other. So we have this problem of matching the categories and putting everything together. Then the second problem that we have is that the situation is completely different in developing countries. Because in the most of developing countries, we have no land cover maps, absolutely no land cover maps. And therefore, a map at resolution of 30 meters is the only piece of information that we have available. So it is important to have this product, and it is important to let people in the developing country know that those products are available, and let them know also how to use these products. So they have to be aware about the fact that those products are available, and they have to be able to use them and possibly to also validate them before in order to check if the map fits their purpose. Why I'm saying that? The map is a global map. The map is a global one. So being a global one derived from satellite imagery, it has been validated, so assessed in some part of the world, but obviously it has not been assessed everywhere in the world. So before using it, it's much better if the local authorities or the people who want to use them, make some assessment before in order to see if also in their region is a good map or not. Okay, so the two main points we are interested in is to provide awareness of the existence of those maps, and also to provide the capability to perform high-resolution land cover map validation and intercomparison to determine if those maps can be used for the specific application the people are interested in. Okay, so we are speaking about validation, so it is better before to ask ourselves what we mean when we speak about validation of a land cover map. The meaning of validation has changed, or the way for validating the map has changed in the year. At the very beginning, we are speaking about 1975. 1975 was the beginning of the production of land cover maps. At the beginning, the validation was simply a visual checkup. So look at the map and say, oh, yes, the map is looking good. So, good. It is validated. Then the second step was to give a global validation considering the percentage of the territory covered by one class in the reality and so the ground truth and in the map, and to see if this percentage was respected more or less. Like, suppose that we are creating the land cover map of Milan and surrounding, and suppose that we give an evaluation that the urban area is more or less the 75%. What we are expecting making the computation on the map is that on the map we find that the 75% of the pixels are classified as urban. And in this case we have, it was considered as validated, a good map. Okay. More recently, we are using other tools for validating the map, and specifically we are using indicators derived from what is called the confusion or error matrix. And we will see what is this confusion and error matrix. But before explaining the confusion and error matrix, we have to think also about how to do the assessment. We already spoke about sampling the field. Sampling the field means taking some sample here and there for two reasons. You can take samples for creating the thematic map, describing the field, or you can also sample the field for validating a map that you have already created. In the specific case of land cover maps, the land cover maps are derived mainly using satellite imagery. So the information is a continuous one, and it is provided as pixel-based images, as pixel-based information. We have a map that is continuous. We want to assess the map to verify the quality of the map. So it means that we need to make measurements on the field, but obviously those measurements can't be continuous. It means that we will go in specific points and sample what's happening in those specific points. It means that we can't go everywhere for assessing the map. We have to decide how many points, and we have to decide the strategy for sampling. We already saw some general strategy for sampling the field. We spoke about random sampling, or we spoke about random stratified sampling, and so on. So in the case of land cover, luckily there are defined some procedures that you have to follow if you want to assess the map. And those procedures are procedures referring to standards. You see here the standards of reference for sampling the field. Okay, so at that point, suppose that we have a strategy for sampling the field, and we have those pieces of information that represent the ground truth in certain points. Or the second possibility is that we have a higher resolution land cover map. Consider, for instance, the situation in the Lombardy region. I told you that for Lombardy, we have an higher resolution land cover map, which is better than Global 30. Global 30 is global. The land cover map of Lombardy is just for Lombardy, but Global 30 has 30-meter resolution. The land cover map for Lombardy has more or less 2, and generally we prefer to say 5-meter resolution in order to avoid every possible error. So 5-meter resolution against 30-meter resolution. Okay, so we can use also this higher resolution map for validating the Global 30, obviously, because we know that the quality of the land cover of Lombardy is better than the quality of Global 30. And in this case, in case of the Lombardy land cover map, we have that the map is continuous as well. So, in assessing the quality of a global land cover map, we can consider at least two cases. One case in which we make measurements here and there, following some sampling strategy. And the second case in which we have on some portions maps, land cover maps that are higher resolution and are continuous, and so we can use also those maps for assessing the quality of Global 30. Okay, let us say something about what is the error matrix. So now we know how to sample the surface. Let us build the error matrix. In building the error matrix, we have to consider two different quantity. The first one is the map, the land cover map that was computed, like, for instance, the Global 30. The second one can be the data set corresponding to the points where I made the point sample, or can be the reference map, which is the higher resolution map that I use for assessing the global authority. So in any case, I'm comparing two different pieces of information. Global authority, or the global map, against points, or the global map against a higher resolution map. Suppose that this one is the global map. It means in the first case that I make some measurements here and there, like for instance in this point here. And in this point here I discover that the measurement in the field is exactly the same as the category that is reported for the map. Or suppose that I make a measurement also here, and I discover that the measurement here is different with respect to the land cover category that I have on the map. So in this case, the map is correct. In this case, the map is not correct. Okay, so at this point, if we have a situation, a pointwise situation like this one, we can build up the confusion matrix in this way. We consider on a matrix with 2 dimensions. We are here the ground truth, so the reference map. We have here the classified map, the map derived from classification, which can be, for instance, global authority. We have that the categories are the same. What we put here in the diagonal are the number of elements that are corresponding to category A for the ground truth and category A also for the classified map. Outside the diagonal, we will put the elements that are classified as A for the classified map and the different categories for the ground truth. So the values that are wrong. Okay. Once we have built up this kind of matrix, we can compute the marginals corresponding to the matrix, and we can compute also the total number of sample units. This is the complete confusion matrix. Starting from this confusion matrix, we can compute many indexes. The first index that we can consider is what is called the overall accuracy. The overall accuracy is the index evaluating the percentage of correctly classified sample units. Let us see what is in this case the index. The index means that we have to consider the sum of all the elements along the diagonal, so the correct sample, and to divide it for the total number of unit sample. In this case, we have the percentage of the sample that are correct in the global land cover. Okay, this is the first index, the very general one. We can derive also some index for the different categories. Specifically, the second index that I want to introduce is the index called the producer accuracy. It is an index indicating the probability that the classifier has labeled a sample unit into the class I, given that the ground truth is in the class I. If you look at this formula, this producer accuracy is not a general one for every class, but is a specific one for one specific class. So, which is the accuracy in the classification of one specific class. Okay? We can derive a similar index considering, instead of considering the values here, so the values corresponding to that one, considering those values, and in this case this is called the user's accuracy. It is the same, but I divide by those terms, and the user's accuracy corresponds to the commissioner. It's the, how to say, is the 1 minus the commission error, while the producer accuracy is 1 minus the omission error. Okay, then we have other main indexes. Another index is the allocation disagreement. Allocation disagreement measures the disagreement in the location. It means that the percentage of pixels of belonging to the different categories can be correct, but they are not located in the correct place. Or the other index is the quantity disagreement, that on the opposite is measuring the percentage of the disagreement in the different classes. Those are just some of the indexes that are generally used for assessing the map. I can show you the laundry list of indexes that are used. There are some that are derived from this overall accuracy, producer accuracy, and user accuracy. You see here the list. There is another one that takes into account the different percentages of the pixel belonging to the different classes, because the different classes are not homogeneously distributed on the territory, obviously. There are other indexes that can be derived from the information theory, and there are other indexes again that are derived from an index that is called kappa. We don't enter into the detail of the formula of all those indexes, but all those indexes are indexes that can be used by different researchers or agencies and so on for assessing the map. Okay, so if those are the tools that, the theoretical tools that we need for assessing the map, and we saw also that it is possible to assess the map or sampling the field or having a higher resolution land cover map, let us see which are the practical tools that we have available for doing such. And as usual, we start having a look at what is available in the free and open source software packages. About that, what is available for land cover, we can mention different GIS or different tools. Some of them are not specific GIS, but they have also some GIS functionalities. You already know some of those products. We will spend some more words with the products that are new for you. And specifically, we can mention QGIS, that is a software that you know. We can speak about GRASS, which is another GIS that you have not used, but you know that is also a GIS in the back of QGIS if you want to use spatial functionalities and so on. There is another GIS that can be used, that is Saga Gis. And then there are two products that are the first one, Orfeo Toolbox, is a product of the Centre National d'Études Spatiales, so the Space Agency of France, French. And there is another one, which is SNAP, that is a product for downloading and processing the data, the satellite data, and it is a platform made available by the European Space Agency. Let's have a look at what is available in this software. Referring to QGIS, if we are interested specifically in the land cover, there are two dedicated plugins. The first one, which is the semi-automatic classification plugin, is a plugin allowing you to make also the supervised and unsupervised classification of satellite imagery for obtaining your land cover map. So you can derive your land cover map starting from satellite imagery. Much better if you do that after having attended the course of Earth observation in such a way that you know also from the theoretical point of view what you are doing. But next year you have also the course of Earth observation, so don't worry about that. Then suppose that I have my land cover map, or I have the data where to assess my map, for instance, because I wandered around in the city collecting data with a land collector, and therefore I have point data taken in the field for validating my land cover map. Okay, and the other thing that is available is the tutorial. So there is not only the plugin, but there is also the tutorial explaining how to use it. What is interesting also is that this plugin allows me in computing the confusion metrics and computing some of the coefficients, some of the indexes we saw before. The plugin is available for QGIS 2, but recently it was rewritten also for QGIS 3. The second plugin that is available, unfortunately, is not so good because there is no enough learning material available, and the development of the plugin stopped in 2014. So you can have a look, but as a matter of fact, it seems to be a bit old and not updated. Okay. If we consider GRASS is, we can say, less user-friendly than QGIS, but it's much powerful than QGIS. So if you need to process a big amount of data, definitely GRASS is better than QGIS. And for people who are expert in GIS, it's not a problem using GRASS instead of QGIS. Considering GRASS, you have a lot of models for classifying data, so for creating the land cover map, and you have the possibility of computing the error matrix and computing the index that you see here, so the kappa, conditional kappa, overall accuracy, user accuracy, and producer accuracy. So some of the indexes that I showed you before. You have also a reference material, and you have also a tutorial for learning how to classify data. So it is enough complete. If we consider a fair toolbox, we have also the possibility of making the classification of the data starting from imagery. There is a tutorial explaining how to do that. There is the possibility of computing the confusion metrics, and there are some indexes, some few indexes, specifically the overall accuracy, user accuracy, and producer accuracy. So we have some of the indexes that we mentioned before. If we consider Saga, so Saga is another GIS. We are not using that GIS because there is no time for showing you all the different products, but as a matter of fact, it's a good product all the same. So in this case, it is possible to make the classification. We have a tutorial on supervised and supervised classification, and it is possible to compute the error matrix with these two indexes, the kappa and the overall accuracy. As last, I want to mention the Sentinel Toolbox that is part of SNAP, this platform made available by the European Space Agency. It is a very good platform for classifying data. So if you want to create your land cover map, but unfortunately there is nothing available about validation and intercomparison. So nothing available for validating your data. It's only possible to derive the data. But for deriving the data, so creating your land cover map, there is a lot of material, training material available in different ways, videos, slides, and everything you need for learning how to derive a high-resolution land cover map. Okay, so if this is the situation, We decided within a project that is was a project under the umbrella of the International Society of Photogrammetry and Remote Sensing, we decided to provide some training material to be used also in developing countries in such a way to allow people in learning how to assess the globe land cover maps for deciding if they are suitable also in their region for their purpose or not. Obviously, in this case, as it is something specifically conceived for developing countries, we decided to reuse only open source software, so concentrating on open source software. As we saw that we don't have one product providing all the possible indexes that can be considered for evaluating the quality of the product, we decided to create something ad hoc, so to develop some specific plugins for doing exactly this activity of computing all the indexes in such a way to be able to completely assess the quality of the data. You find all the material that I'm mentioning now on this website. It means that you find there the link to the GitHub where you find the software that was developed. You find the slides that are used for the tutorial, and you find also the training data that you can use for training yourself and doing exactly the same exercise that is explained on the slide in such a way to be sure at the end to do exactly what we are expecting you to do. Okay, the plugins were developed for QGIS and were developed as PyQGIS tools. You can download the two plugins directly from the GitHub here, or there are many possibilities for downloading the software. So you can download the software. Then, as a matter of fact, we have two different plugins. One plugin is in case we want to validate the data having samples that are point-wise samples. So, like in the case of the land cover collector that you are using for going around and collecting the category of the land cover. These are point observation. And so we have a first plugin helping us in assessing the data in this case. The second case is a case applying for raster data. It means that we start with the higher resolution raster map, and we can validate or assess the global raster map starting from a local raster map with higher resolution. Okay, so you see here the name of the two plugins that were developed. And you see here how they are, and you have to introduce the pieces of information of interest and so on, and then you simply run them within QGIS. With respect to the data that are provided, because we provide you also some data in such a way that you can train yourself in using that, the data that we decided to use is Global 30. Global 30 is a raster map. We have 10 classes. The resolution is 30 meters. And we decided to use the map corresponding to 2010. Then with respect to the point data, we decided to use the Lucas dataset. Lucas dataset is a dataset which is a point-wise dataset. It is an authoritative one. It is produced by Eurostat, the Statistical Office of European Commission. We have 8 main classes plus many subclasses, so it means that we don't have exactly the same categories of Global 30. We needed to make the link between the different categories. It has not resolution, as a matter of fact, because it is a point observation. So exactly in that point, this is the value of category exactly in that point. The year is the 2009, because unfortunately we don't have the Lucas for 2010. So we see that there is a bit of discrepancy of 1 year, but we don't have the Lucas for 2010. And the area which is covered is 23 European countries. Then with respect to the raster dataset, we propose you to use this map that is called DUSAF. This is the land cover for Lombardy. It is not a raster map. It is a vector map. It is a polygonal vector map. So it means that if we want to use our plugin, we need before to rasterize it. It has 5 main classes plus many subclasses. So again, different with respect to Global 30 and different also with respect to Lucas, unfortunately. The resolution is at scale 1/10,000, and so we decided at the end to rasterize it with a pixel size of 5 meters to be enough sure that it is compliant with the scale of the map. Unfortunately, we don't have the DUSA for 2010, so we must use the DUSA for 2012. And this is the land cover map of Lombardy region. Okay, so we have these 3 maps. What is the data pre-processing that we need to do before starting the computation of the error matrix and the indexes? Let us start with the Global 30. So, first of all, Global 30 is composed by different tiles. First point, we need to merge all the different tiles for all the Europe, all the different countries in Europe. Then, but this is just a detail, we need to remove no data. We need to reclassify the classes in such a way to create the link between the classes in Lucas and the classes of Global 30. And this has to be done manually. So I have to decide that, for instance, artificial land in Lucas correspond to artificial surfaces in Global 30. That cropland correspond to cultivated land. That shrubland and tundra correspond to shrubland tundra, but also woodland correspond to forest, and so on and so on. So I have to make the link between the 2 classes, and then I have to reproject both of them with the same projection, because Lucas is giving in European projection, and Global 30 being a global land cover is not given obviously in the European projection. So I have to reproject them in such a way to have the same. Once I've done this, I can start the plugin, and the plugin creates for me all the indexes that I need for evaluating the quality, for making the assessment of Global 30 starting from Lucas. If we consider on the opposite DUSAF, I told you that it's a continuous map only for Lombardy. The plugin we have is a plugin for raster map. So at the beginning we need to rasterize the map, rasterizing the map at 30 meter resolution. And then the second point is that we need to reclassify the DUSAF accordingly with Global 30, exactly as we did before with respect to Lucas. And we have to do that manually. The best way for doing that is to look at the definition in the 2 land cover and to find the best match. But you see that in this case, as DUSAF is much more details, for instance, in corresponding to artificial surfaces, you have much more classes in those. So much more classes corresponding just to one class in Global 30. Okay, so at this point you create the match, you run the plugin, you compute the error matrix, and you have the value of your indexes. And therefore you are able to understand if the map is a good map, Global 30, is a good map also in your region, and it is good for you for using it for your purpose, or it is better not to use it. So it's a validation. There are validation tools that can be reused everywhere in the world by everybody for assessing the quality of a global product in a local region. Okay, I think that this is that for the general description of the project. I don't know if you have questions about that, if there is something not clear. Now we have, because I know that you have, because I assigned you as project, the project of collecting land cover data, samples, point samples, and then the aim was of collecting and then creating a WebGIS showing the data. But now you know that you have one more tool available. The one more tool is to make the assessment of Global 30 starting from the data that you collected. So one more tool available for making such.